This lesson is on factoring greatest common factor. A GCF is the largest factor that two or more terms have in common. Example number 1. To find the common factor of this polynomial, find the prime factorization of all three terms together. So we have 12x squared, 9x, and 3. A prime number that will divide into all three of these terms is 3. 3 goes into 12x squared, 4x squared. 3 goes into 9x, 3x, and 3 goes into itself once. Look to see if any other prime factors will divide into your terms. You cannot divide any prime numbers into 4x squared, 3x, and 1, so we will stop. The GCF will go at the beginning of your answer and then make a leftover parentheses. These terms, 4x squared, 3x, and 1, will be your leftovers. The signs will be the same as what's in your original problem. So we have 4x squared plus 3x plus 1. That is your final answer when factoring the GCF. You can check your answer by multiplying 3 back into the parentheses to see that you get your original problem. Example number 2. Again, we'll look for the common factor of all terms. Do prime factorization on 40x to the 4th and 24. A 2 can divide into both. 2 goes into 40x to the 4th, 20x to the 4th. 2 goes into 24 12 times. Continue to divide by prime numbers. So 2 will go into both. 2 goes into 20x to the 4th, 10x to the 4th, and 2 goes into 12 6 times. We can continue to divide by primes. 2 will go into both of those. 2 into 10x to the 4th is 5x to the 4th, and 2 into 6 is 3. Here we will stop because there's not a prime number that can go into 5x to the 4th and 3. So our GCF will be found by multiplying 2 times 2 times 2. That GCF that will factor out is an 8, and then make your leftovers parentheses. Your leftovers will be these terms here at the bottom of your prime factorization. So we have 5x to the 4th minus, because we had that in our original problem, 3. Again, you can check this by distributing the work back together to see that you get your original problem. Example number 3. Again, find the prime factorization for each term. We'll start with dividing by 2. You can choose to divide by any prime number that will go into all the terms. I start with the smallest prime. 2 goes into 90x to the 3rd, 45 times, and your x to the 3rd. 2 goes into 50x, 25x, and 2 goes into 10 5 times. Continue to divide by primes. The next prime that will divide into all those terms is a 5. 5 goes into 45x to the 3rd 9 times, and bring down your x to the 3rd. 5 goes into 25x 5 times, and bring down your x. Finally, 5 goes into 5 once. Your GCF will be 2 times 5 in front of your parentheses, and then you'll put your leftovers, which are these terms here at the bottom of your prime factorization. So we get 9x cubed minus 5x plus 1. Again, you can distribute 10 times 9x cubed gives you 90x cubed. 10 times negative 5x gives you negative 50x. And 10 times 1 gives you 10. To see this is the correct factored form of that problem. Example 4. We'll now see what it looks like to factor a variable as the GCF. So again, we have x to the 7th, x to the 5th, x to the 3rd. Again, we'll look for the prime factorization. See what they all have in common. So first, they all have an x in common. So x divided into x to the 7th. Remember your exponent property. X to the 7th divided by x, you'll subtract those exponents. So you'll decrease each exponent by 1. So again, look and see what they all have in common. They have another x. So once again, we'll decrease the exponents by 1. They still have an x in common, so we'll divide by another x, making each of the exponents once again decreasing by 1. Notice x to the 0 equals 1. So for that leftovers, you would just put the term 1. Rather than individually dividing by x's, you can look at the smallest exponent, and that will be your greatest common factor when working with variables. Let's see what that looks like. The smallest exponent is x to the 3rd, so we know that that will be our greatest common factor. When you divide x to the 7th by x to the 3rd, again, subtract the exponents. So 7 minus 3 is 4. X to the 5th divided by x to the 3rd. Subtract those exponents gives us x squared. And x to the 3rd divided by x to the 3rd is x to the 0. Or we can just say that equals 1. We get you the same answer with fewer steps. So let's write our answer in factored form. Here we have x times x times x, so you can add the exponent, and it's x to the 3rd. Or if you use the quick method, we see that it's x to the 3rd is our GCF. Our leftovers will be here at the bottom of your prime factorization. We have x to the 4th plus x squared plus 1. Let's look at another one with factoring variables. Example 5. Let's start with just dividing by x. X into 29x to the 5th, subtract the exponent just by 1. So we get 29x to the 4th, and x divided into 17x squared. Again, just subtract that by 1. So we get 17x to the 1st, which is just 17x. You still have another common factor of an x. So 29x to the 4th divided by x is 29x to the 3rd, decreasing by 1 on the exponent. And x divided into 17x is 17x to the 0. But x to the 0 just equals 1, so that's really just 17 times 1, which is 17. Or the quick method is to look at the smallest exponent on your variable, and that will be your common factor. X squared. When you divide x squared into 29x to the 5th, subtract 5 and 2, and that gives us x cubed. Again, 17x squared divided by x squared will give us 17x to the 0. And like we've already talked about, x to the 0 is 1, so that's really just 17 times 1, which is 17. So let's write our answer in factored form. Our GCF is x squared because we have x times x. We add those exponents, gives us x squared. Or if we use the shortcut method, you see our GCF. Write your leftovers parentheses using the terms at the bottom of your prime factorization. 29x cubed minus 17. Be careful to remember to use the same sign that was in the original problem. Try number 6 on your own. Press pause to work this out. Check your work for number 6. The answer should be 9 times 4x to the third minus 3x plus 1. Example 7. Try this one on your own. Press pause to work it out. Check your work for number 7. The answer is x to the 8th times 13x to the third minus 4.